Hello everyone, I welcome you all for the video lecture in Python. Today, let us discuss on the topic function composition and recursion for building elegant solutions. Let us explore two fundamental programming concepts: mastering function composition for cleaner code. Let us understand recursion for elegant problem solving. We will unlock modular, reusable, and efficient designs. We will embrace functional programming styles. Functional composition, the building blocks. The functional composition combine functions. Simple functions merge into complex ones. Think of them as modular components. Readable code. The function composition improves code clarity. It makes logic easy to follow. Data pipelines. Data transforms like an assembly line. Each function does one step. Function composition. The practical applications are data processing, UI rendering, mathematical operations, and web frameworks. Data processing, meaning chain operations like filter, map, reduce. It builds powerful pipelines. In UI rendering, it meaning it is the connection of data to components, rendering complex user interfaces efficiently. Mathematical operations, it compares functions for calculations. Example, square of absolute of x. Web frameworks. We have express.js. It uses middleware chains. It processes requests step by step. Function composition. The advanced concepts are carrying, piping or chaining, functional purity. Carrying meaning functions take arguments one by one, creates specialized functions. Piping or chaining meaning data flows through functions left to right, simplifies transformations. Functional purity, meaning no side effects, enhances composability. Functions are predictable. Recursion, that is self-referential solutions. Function calls itself. It solves problems by breaking them into smaller identical subproblems. The base case for recursion is essential, which stops the recursion. It prevents infinite loops. Recursive step calls the function with a modified input. It moves closer to the base case. Recursion use cases and considerations. Common uses are factorial calculations, Fibonacci sequences, tree traversals, especially depth first search. The advantages are concise, elegant code for recursive problems, expressive solutions. The disadvantages are potential for stack overflow, deep calls consume memory. Recursion, optimization alternatives, tail recursion, compilers optimize this, reduces stack usage. Memorization, cache results for speed. It avoids redundant calculations. Iteration, often more efficient. Use loops for non-recursive problems. Conclusion: the power to you, clear data flow, function composition for organized data transformation, problem decomposition, recursion for elegant self-referential solutions, powerful code for writing declarative, maintainable, and robust software. Thus, coming to the end of today's session, I hope you enjoyed the video. Thank you.